Good evening, everyone. We'll wait for more 5 minutes if anyone else is going to join, or we'll start the class by 7:10. Okay, so just wait till that time. Thank you. Okay, good evening everyone. We are going to start with the class. So, today we are going to discuss questions for week 6. So, I hope you all are doing the current year assignments properly because those carry marks. So, I hope you all are sincerely doing it and submitting it on time. So, today we are going to discuss around 13 questions from the lecture material of week 6. Okay, so I hope you all are thorough with the week 6 material, study material, right? So, you all are getting only study materials for each week, I guess. So, there is no other option but through go through those slides and be prepared, right? So we'll see today how much you're prepared with the week 6 material. We'll start, and I hope everyone knows the rules for the class. Please keep yourselves mute throughout the class, audio and video. If you want to share anything with me or discuss anything with me, please write it down in the chat box. I will look into it. And what else? Yeah. So, and I will be showing you the question. You will be given around 2 to 3 minutes of time, and then I will show you what is the correct answer and a possible explanation for it. Okay, and if you have any doubts from the questions we are discussing, please write down in the chat box. Okay, and yeah, that's it. So, we'll start with question number 1. Please write down whatever you think is correct according to you in the chat box. Your answer of choice. Okay. So, starting with the first question. During ethanol fermentation from molasses, what is the optimal pH range maintained to favor yeast growth and inhibit bacterial contamination? So, they are asking about the pH range 3 to 3.5, 4 to 4.5, 5.5 to 6, 6.5 to 7. Start answering. I need answers from everyone who has joined the class. There are less people, so I can know who is answering and who is not answering. So please be active and answer. Okay. Okay. Everyone is done. Let's see what is the correct answer. It is 4 to 4.5. So 4 to 4.5 is the optimal pH range which supports the growth of yeast but not bacteria. So a slightly acidic pH. So below 7 it is the acidic pH. So 4 to 4.5 supports optimal growth of Saccharomyces cerevisiae, which is the budding yeast, right? While inhibiting bacterial contamination. At pH below 3.5, yeast activity decreases, whereas higher pH favors bacterial dominance. So for the optimal range for yeast growth is 4 to 4.5. Okay, 1 minute. Someone is trying to join. Yeah. So the optimal pH for yeast growth is 4 to 4.5. But if you go below that, like if you make it more acidic, like 3.5 or below, then yeast growth also is inhibited. However, for bacterial growth, the range is high, like above 7. That's like basic pH leads to bacterial dominance. So during ethanol fermentation from molasses, if you keep the pH slightly acidic, not too acidic or not too basic, it is good so that it can prevent bacterial contamination and favor the yeast growth. For fermentation, yeast growth is required. So in that pH like 4 to 4.5, it can help in yeast growth, right? I hope this is clear. It was pretty easy. Moving on to the next question. In ethanol fermentation using molasses, which of the following vitamins is present in higher concentration in canned molasses compared to beet molasses? Biotin, pantoethanol, ionositol, vitamin C. Start answering. Okay, is everyone done? Okay. Let's see what is the correct answer. It is A. Biotin. So, can molasses contain 2.7 to 3.2 mg per liter of biotin, whereas beet molasses contain only zero point zero 0.09 to 0.13 mg per liter. So, biotin plays a significant role as a cofactor in yeast fermentation pathways, supporting ethanol production. So it was written which is the vitamin which is present in high concentration in can molasses but not in beet molasses. So here are the concentrations. So the correct answer is biotin is present in higher concentration in can molasses compared to the beet molasses, right? Okay. Moving on to the next. Which of the following statements correctly differentiates high wines from low wines obtained after ethanol distillation? High wines have higher methanol content. High wines contain 60 to 90% ethanol. Low wines are discarded as waste. High wines are unsuitable for further purification. Start answering. Okay, is everyone done? Okay, I'll wait one more minute before we start with the discussion. Okay, I think it's. Let's see what is the correct answer. It is high wines contain 60 to 90% ethanol. So during distillation, fractions containing 60 to 90% ethanol are called high wines. So with higher concentration of ethanol, they are called as high wines, whereas lower concentration of ethanol categorizes for the low wines. With while those with lower alcohol content are low wines. So low wines can be redistilled to recover ethanol. So I think that was a pretty easy question to understand that what correctly differentiate high wines and low wines. So it is the ethanol content in both which actually differentiates both of them, right? Moving on to the next. In the biostill process for ethanol production, which unique feature reduces effluent generation? Use of genetically modified yeast, continuous recycling of yeast back into the fermenter, high pressure vacuum distillation, elimination of nutrient supplementation. Start answering. keep noting down how many correct answers and how many wrong answers you all are giving. We will see your scores at the end of the session. Okay. Okay, is everyone done? I'll wait for more 1 minute. Okay, let's see what's the correct answer. It is continuous recycling of yeast back into the fermenter. So, in the biostill process, what happens? That reduces the effluent generation. It is the continuous recycling of yeast back into the fermenter. So the explanation is written as follows. The biostill process operates continuously and recirculates yeast back into the fermenter, resulting in high cell density, faster fermentation, and reduced effluent generation. So because they keep recycling the yeast continuously in the fermenter, it leads to a higher cell density. There is a faster rate of fermentation, as well as there is reduced or decreased effluent generation. So this is a good process, that is the biostill process for ethanol production. It is effective as well as economical. Moving on to the next question. Question number 5. In brewing, which compound derived from hops contribute to bitterness and biological stability of beer? Tannins, resins, myrcene, catechol. Start answering. Hello. Hmm. Hmm. Call. Hmm. 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 ଆଶ୍ଚର୍ଯ୍ୟ ହବ। ସେଇଟା ମୋତେ ଜଣାଲା, ତାଙ୍କ କଥାର କିଛି ଗ୍ୟାରେଣ୍ଟି ନାହିଁ। ହୁଁ ସେୟା ତ ଭାବୁଛ ତମ ରୁମମେଟ୍ ମିଳିଲା ପରେ ସେ ଯିବ ବୋଲି, ତ ହୋପ୍ ହିଁ ଛାଡ଼ିଦେଲି କି ଆଉ ସେଇଟା କେବେ ହବ ବୋଲି। ସିଏ ହଁ କରୁଛି, ଚାକି ମାନେ କିଛି କରିବେ ବୋଲି ମତେ କାହିଁ ଲାଗୁନି। ଗୋଟେ ଜିନିଷ ପାଇଁ ଏତେ ଧାଇଁବାକୁ ପଡୁଛି ହେଲା, ମାନଙ୍କୁ କିଛି ଫରକ ହିଁ ପଡୁନି। ତମକୁ ତ ଏଚଆର ବି ମିଳିବ ନା। ସେଇଟା କଥା। ହୁଁ। ଦେଖିବା ଆଉ ଥରେ ଯାଇ ଆମକୁ ଫଲୋ ଅପ୍ କରିବାକୁ ପଡ଼ିବ ସେ ୱାର୍ଡେନ୍ ସହିତ। ହୁଁ। ସେୟା। ଠିକ୍ ଅଛି। Okay, is everyone done? Let's see what is the correct answer to this question. Yeah. So it is raisins. So hops contain raisins that impact bitterness and provide antimicrobial activity, enhancing beer's biological stability. Tannins mainly help in protein precipitation, and essential oils contribute to aroma rather than bitterness. So the question was, in brewing, which compound derived from hops, which is raisins, not the other ones, contribute to bitterness? And because I don't know if anyone has tasted beer, they can know that it is bitter in taste, and also in brewing there should be biological stability and no other contamination or any other growth of microbes. So to prevent that, these raisins are used that impact the bitterness and provide antimicrobial activity, enhancing beer's biological stability. Whereas tannins, which was given in the option, is used for protein precipitation, and these essential oils, that is catechol and myrcene, are used to give aroma rather than bitterness. Okay. So moving on to the next question. Question number 6. Which statement correctly distinguishes top fermenting yeasts from bottom fermenting yeasts used in brewing? So top fermenting yeasts operate at lower temperature than bottom fermenting yeasts. Top fermenting yeasts produce larger beer, Top fermenting yeasts require warmer temperatures and produce beers like ale and porter. Top fermenting yeasts are used exclusively in wine production. Start answering. Okay, let's see what is the correct answer to this question. It is C. So, top fermenting yeasts require warmer temperatures and produce beers like ale and porter. That's why they are called as top fermenting yeasts, because they need higher temperature, right? Not it's the distinction is based on the temperature, and they produce beers like ale and porter. So the top fermenting yeasts rise to the surface. They are on the surface, require 10 to 25 degrees and produce ales, stouts, and porters. Bottom fermenting yeasts settle at the bottom, ferment at 7 to 15 degrees, and produce lagers. Okay, so this is pretty clear. I hope you understand now what is the differentiation between the top fermenting yeasts and the bottom fermenting yeasts, right? Moving on to the next question. In the wine making process, potassium metabisulfite is added primarily to increase sugar content, enhance fermentation rate, destroy wild microorganisms, and act as a preservative, reduce tannin levels. Okay, start answering. Okay. Let's see what is the correct answer. It is C. Destroy wild organisms and act as a preservative. So the potassium biosulfite releases SO2, which inhibits spoilage microorganisms and prevents contamination prior to yeast inoculation. It also acts as an antioxidant, helping preserve wine quality. So the wine making process may they use potassium metabisulfite, which prevents in contamination prior to the yeast inoculation, prior to the fermentation process. So it acts as an antioxidant and preserves the wine quality, because once a wine is made, it is stored for years and years. So proper uh, carefulness is very much needed while making it, while fermenting it, and also to prevent contamination in the future. It has to be made that it can be preserved for years and years. So for that, potassium metabisulfite is used. Moving on to the next question. During wine fermentation, why is oak wood preferred for fermentation vessels? It imparts desirable aroma and color. It accelerates yeast metabolism. It maintains sterile conditions naturally. It prevents sugar crystallization. Start answering. Okay, let's see what is the correct answer. It is A. It imparts desirable aroma and color. So, why is oak wood used during the wine fermentation? So that it gives that rich color and aroma to the wine. So, oak barrels enhance the flavor, aroma, and color of wine while allowing mild oxygenation that aids wine maturation. Stainless steel containers are used when minimal flavor alteration is desired. Okay. So this was easy. Moving on to the next question. In vinegar production, which microorganism is primarily responsible for converting ethanol to acetic acid? Okay, this is a very easy question. You all must have read from the school level itself. Saccharomyces cerevisiae, Acetobacter species, Lactobacillus species, Zymomonas mobilis. Start answering. Okay, let's see what is the correct answer. It is B, Acetobacter species. You can see the question was what is used in converting ethanol, which microorganism is primarily used in vinegar production for converting ethanol to acetic acid. So acetic acid, so it is Acetobacter species. From the name itself, you can know it is Acetobacter species. So what happens? Acetobacter species oxidize ethanol aerobically into acetic acid. You can see there is release of water. This process is known as the oxidative fermentation and is essential for vinegar production. Okay. Moving on to the next question. What is the ideal ethanol concentration for efficient vinegar fermentation? 5 to 7%, 10 to 13%, 15 to 18%, 20 more than 20%. Start answering. Okay, let's see. The correct answer is 10 to 13%. So, the ideal ethanol concentration for efficient vinegar fermentation is 10 to 13%. Okay, so higher concentrations, that is more than 14%, can inhibit acetobacter activity, whereas lower concentrations reduce vinegar yield and quality. So the acetobacter which we learnt about in the previous question is needed. So more than 14% of ethanol concentration can inhibit its activity, so we do not recommend it. And lower concentrations can reduce the vinegar yield and quality, so that is also not recommended. So the proper concentration is 10 to 13% of ethanol, right, for vinegar production. Moving on to the next, in the German process of vinegar production, what is the purpose of using beech wood shavings? To enhance aroma, to provide a large surface area for acetobacter growth, to remove impurities, to filter the final vinegar. Start answering. Today was all about wine making, ethanol fermentation, and vinegar production, right? Okay, let's see what is the correct answer. It is B, to provide a large surface area for Acetobacter growth. So, in the German process for vinegar production, they use these beechwood shavings so that they provide a large surface area for Acetobacter growth. In the generator process, the beechwood shavings are used to increase surface area, supporting the growth of Acetobacter biofilms and accelerating ethanol oxidation to acetic acid. So the acetobacter reaction is needed so that the ethanol can get oxidized to acetic acid. So for that there is a need of larger surface area. So for that these beechwood shavings are used in the generator process. This is a German method for vinegar production. Moving on to the next question, which factor does not affect the efficiency of vinegar fermentation? Oxygen supply, temperature of the medium, presence of nutrients, color of the supporting medium. Start answering. Okay, let's see what is the correct answer. It is D, color of the supporting medium, obviously. So the color of the medium does not matter or does not have any kind of effect on the efficiency of vinegar fermentation. So key factors influencing the vinegar fermentation include oxygen availability, ethanol concentration, nutrients and temperature. We all have all discussed it in the previous questions one by one, right? But the color is not at all required or doesn't matter for any kind of fermentation efficiency. Okay, so yeah, this is the last question. Which of the following statements about synthetic versus natural vinegar is false? Synthetic vinegar is made chemically using acetic acid. Natural vinegar is produced biologically by Acetobacter species. Fermented vinegar contains extra metabolites like aldehydes and butanol. Synthetic vinegar has a richer aroma than natural vinegar. So which of the statements is true? You have to select. Start answering. Okay. Is everyone done? Okay. Let's see what is the correct answer to this question. It is D. Synthetic vinegar has a richer aroma than natural vinegar. This is the false statement. Okay, so out of all the four options, this is the false one. Other three are correct. Natural vinegar contains secondary metabolites like aldehydes and esters and butanol that enhance the aroma. So natural vinegars have a richer aroma, whereas synthetic vinegar does not have these compounds and hence have a less complex flavor profile. So the opposite was written, that synthetic vinegar has richer aroma, which is a false statement, right? Yeah. So this was the end of today's live session. If you all have any kind of doubts, you can ask me. Shanmukha, Priya, you said you have some doubts. You can let me know the questions. If those are from the current year assignments, I can check it in the portal. And yeah, whoever attended today's session, if you have any doubts in any of the 13 questions we discussed, you can ask me now, or else week 1, ninth one. Okay, you said the question number. Okay, and week 3, sixth one. Okay, I'll note it down. I'll check it. If I am able to do it, I'll definitely let you know in the next week. Okay, yeah, noted. Anything else? Okay, let me know your scores. What is your scores out of 13? Good. 12 out of 13, 10 out of 13. Okay, nice. Okay, anyone else? 11. Good. Okay, very good. If everyone is able to score 10 or more than 10 out of 13, it's a good score. So you all are doing well in being thorough with the lectures, right? Okay, so whoever is joining late, please try to be on time so that you don't miss out on the questions. Okay, I can know who is joining late, but I won't say the names. Just I will say again, be punctual, be on time, try to attend on the questions in the live session, because obviously it's going to be a hell of a task to again watch it in the YouTube recording, right? So better that you all attend the live sessions, right? Okay, so if no one has any doubts, we can disperse for today, and we'll meet again next Tuesday, 7 o'clock, 7 p.m. Please be on time, and we'll discuss week 7. And whatever questions were told by Shanmukha Priya, I'll go through it whenever I get time, and we'll discuss it next week if possible. Okay, yeah, thank you everyone.